Hi there. This video is my third vlog of my SCH3U course, and this video will be all about explaining the two examples, the polarity inside the CH bound and also the CCl bound. So before explaining the examples, we need to go through the definition of electronegativity and also polarity first. So let's take a look at the first picture, the first PowerPoint. That I gave an example of explaining electronegativity, which is water. So water is made of two elements. It's one oxygen atom and two hydrogen atom. So by drawing the Bruhhhhhhh diagram, we add them together. We can see that they're sharing electrons, which they made covalent bond with each other. And the picture on the right is actually the distribution of positive charges and negative charges. You can just treat the shaded part as the negative charges where the electrons goes. And inside an atom, the electrons is actually distributing in not that balanced. It's random distributed. So there's a property which exists in every substance or element, which is called electronegativity. It is describing the ability to of a substance to fight against the other elements inside a compound that who can get the electrons more easily. So who has a stronger ability to get electrons? So I'm just telling you that oxygen has much stronger electronegativity than oxygen. So in this diagram, you can easily notice that the shaded part, which is the negative areas, was occupied by oxygen, which oxygen occupies most electrons. Well, in this case, oxygen shows a property of positive, while hydrogen shows negative. And this is what we call polarity. And polarity was, the existence of polarity was because of the difference of electronegativity inside an compound. Because different elements, different substances have its different electronegativity. So once there is difference, then polarity occurs. Which means that we're describing a compound if it's polar or non-polar, and we will see later. And this is just a little page that I added about intermolecular forces, which we can see that I just draw two water molecules here, which delta negative above the oxygen indicates that it shows negative because it's occupying, it gets electrons. And well, hydrogen was labeled as delta positive because it gives electrons. It's a donor, it's a donator. So as we all know that positive part will attract negative, like positive charges will attract negative charges, right? So in this case, the hydrogens in one water molecules will attract the others by using hydrogens to attracting the oxygen of another molecule, which in this case it provides a little bit of forces between each molecules. But these forces will not affect each molecules, but it will stick them a little bit together. So here's a relationship I write that actually electronegativity determines polarity, while polarity determines intermolecular forces. Well, electronegativity and polarity was always describing what's happening in one molecule, while intermolecular forces is describing what happens between the molecules. And this is simply the explanation of electronegativity. And here's a chart of the values of it's the difference of electronegativity between elements. So here's the question: how to determine polarity? How to determine if a compound is polar or non-polar? So now we need to apply a new concept, that is the difference of electronegativity inside a substance, inside a compound. So if the polarity is close to each other, so the more similar the electronegativity between two bonded elements, so the more evenly the electron pairs will be shared. So, for example, in diatomic elements, which each element is identical, so hence the electrons are shared completely evenly. In this case, they don't have that much electronegativity difference, and they're non-polar at this case. So there's a limit, which is 0.4. If the number of difference of electronegativity exceeds this limit, then I mean, you can treat this as a polar covalent, like polar covalent compound. And if it's not exceeding 0.4, yeah, sorry, this chart is a little bit unprecisely drawn. If it didn't exceed 0.4, then it can be treated as a non-polar covalent compound. And one thing to notice is that if it's too big, for example, it's higher than 1.8, maybe there's some exceptions. Like there's also some polar covalent compound which the difference is above 1.8, but commonly the compound that is above the difference of electronegativity inside a compound which is above 1.8, we can treat them as all ionic compound because they're extra polar. Okay, so here it is. And by applying the calculations, then we can know that if it's polar or not polar, because by the limit by 0.4. So here's the main topic actually of this video. It's the example that the teacher gives us. So first is to explain the CH bound. And by drawing the Lewis diagram, here's just basically a Lewis diagram. And I'm only drawing one hydrogen because it should be 4, right? Because there's 4 outer shell electrons around the carbon. So by calculating delta En and of CH bound, which is electronegativity difference, we should use the absolute value of electronegativity of H minus by electronegativity of carbon, which by using the periodic table and also the data formula that the teacher gives us, we can gain that the electronegativity number of H is 2.1, while the electronegativity number of carbon is 2.5, which the difference is negative 0.4, but we need to use absolute value, so it's positive 0.4. And because the limit is 0.4, so this difference between H and C does not exceed this limit. So it's actually a nonpolar covalent compound. And finally, it's the last part, which is also the second example, the hydrogen chlorine bound. Also the Lewis diagram. This time is perfectly drawn because there's only one electrons that has to be gained in chlorine. So also the same method. Firstly, to calculate the difference between the electronegativity of H and Cl. Also, by applying the absolute value, we can gain that using electronegativity of hydrogen minus electronegativity of chlorine. Sorry, I also made that mistake. I made that mistake all the time. Just never mind. Which is the absolute value of 2.1 minus by 3, which is 0.9. And obviously, 0.9 is a number that is larger than 0.4, which is the limit of differentiating covalent or polar or nonpolar covalent compound. So in this case, HCl bound is obviously polar covalent. So how to explain, how to show other people like it's a polar compound? By simply draw the diagram below at the most down part, which the arrow should be pointing the element which has the higher electronegativity, and obviously it's chlorine in this case. And because the electron tends to move towards chlorine, so delta minus should be labeled below chlorine, and delta positive should be labeled below hydrogen because it donates the most electrons, the negative charges. Yeah. So that's all for today's video. And I don't think I made a quite clear definition, explanation about this. So I hope you could. I beg you to explain it more clearly in tomorrow's lesson. I hope you could. Thanks for watching, and I'm really thankful if you can watch the whole video because you always skip my video all the time. So that's all. I'm not wasting your time anymore. Bye bye.